As with any nomenclature question, even as we introduce more functional groups, we still have the same first step. We have to identify the largest chain. And in this molecule we can see pretty clearly that our longest chain is this one that I've highlighted in yellow. From here, we need to pick the direction to number it in. Numbering often becomes a little bit more straightforward as we add more functional groups because there are less things to consider. When working with nomenclature of an alkene, we pick the numbering so that the alkene is closest to the end of the chain. However, in this case, the alkenes, both of them, are actually equal distance from the ends of the chain. At that point, in order to pick the correct direction, it becomes like any other question, and we start looking at where the substituents are. From both directions, we have a substituent on the second carbon, but if we go this direction, our second substituent is on the third carbon, as opposed to the other direction, which has the second substituent on carbon 4. So with that, we can start listing the names of our substituents. We have a chlorine at 2, a methyl at 3, an isopropyl at 4, an iodine at 5, and a bromine at 7. So we can now alphabetize these, which gives us 7 bromo, 2 chloro, 5 iodo, 4 isopropyl, 3 methyl, and then our parent name, which is octane. But our octane here has alkenes at carbons 3 and 5, so we need to list each of those. And because there's 2 alkenes, we call it diene. Now, some of the most common wrong answers I see to a question like this stop at this point. But at this point, we've left something very important out, and that is all of the stereochemistry. So I'm going to erase everything I've put in this drawing. And now we can go through and figure out the stereochemistry. And in fact, in this compound, we have 4 places that we have to look at. Carbon 2 is a chiral center, so we have to assign R and S. Carbon 3 is an alkene, so we need to do E and Z. 5 is an alkene, so we also need E and Z. And then carbon 7, where the bromine is also a chiral center. So if we look at the chlorine center, carbon number 2, the chlorine is highest priority, higher atomic number than any of the other substituents at that carbon. We have a hydrogen that's not drawn in, but is pointing forward. That's our 4th priority. And then we have the 2 carbon groups, the methyl versus the rest of the molecule. Methyl with just hydrogens on it is going to get lower priority, and we've assigned our priorities there. Now we can draw our arrow in, and as we see, it's going counterclockwise, which would indicate S. However, because our lowest priority substituent, the hydrogen, is pointing forward, we then have to take the opposite, which makes this carbon 2R. We can also assign stereochemistry for carbon 7, the carbon with the bromine. Again, very clearly, the bromine, the halogen, is higher priority, higher atomic number than any of the carbon groups, so it's number 1. The alkene is 2, the methyl is 3, and then the hydrogen that's not drawn in but is pointing back is carbon 4. In this case, the lowest priority substituent is pointed back. We don't have to make any adjustments. We can draw the arrow in, and we get R here as well. So now we also need to look at the alkenes. If we start with the alkene at carbon 3, that is of course this one, we can look at the carbon on the right first. We have a methyl pointing up versus the ethyl with the chlorine. So we have higher priority here, second priority for the methyl. On the other side, we have a carbon and another carbon. When we look at what those carbons are attached to, the bottom carbon just has 2 additional methyl groups. But this carbon being attached to an iodine will be higher priority. So we have 1 here and 2 here. As we can see, the higher priority substituents are on opposite sides of the molecule, and so that defines that double bond as E. One more double bond to go. That's now this alkene. This is probably the easiest one in the molecule because on the right side of the alkene we have an iodine, which is clearly higher priority than carbon. And on the other side we have a carbon, which we know is higher priority than the hydrogen. So here the higher priority substituents are on the same side. That makes it Z. So finally we get our full name of 2R3E5Z, 7R, 7-bromo, 2-chloro, 5-iodo, 4-isopropyl, 3-methyl, octa-3,5-diene.